Okay. Now in this case, what you need to remember is 3.7, SL 3.7, the circular function sin x, cos x, tan x, amplitude, their periodic nature, and their graphs. Now you have to remember this for one domain. Correct? Trig functions may have domain in degrees or radians. So let's look at sine function. So let's look at sin x. Y is equal to sin x. Now one cycle, remember it's a periodic function. The trig ratio, the sine.
The recording button, sir.
I think so. It is.
No, sir, I was just because it was recording.
Yeah, because yeah, it is there. It is on. Okay, I just removed it to keep it a clean look. So this is 0, 360, one cycle, one crest and one trough is one cycle. 180, 1, minus 1. So this is your parent graph. Y is equal to sin x. So there's no multiple, very pure sin x graph. In radians, what we do?
So same thing, except your 180 will become pi, 360 will become 2 pi.
Same thing, absolutely. This will become pi, this will become 2 pi, this would be 1, this would be minus 1. This is your x. So this is y is equal to sin x. If your domain is in radians. Similarly, you have to remember your cos. So y is equal to cos x in degrees. So if you have in degrees, this is how it is, one cycle. Because your cos 0 is 1. Right? This is 360. This is 180. This is 90. 270. And this is minus 1. Correct? Similarly over here, this is 1, 0, minus 1. So 2 pi, pi, correct? Pi by 2, 3 pi by 2. So this is your y is equal to cos x. This is in your radian. You have to learn this up, huh?
Yes, sir.
Tan.
I know this.
Achha, what is the amplitude? Amplitude is, this is called the amplitude. Amplitude is
The height of the wave.
yeah, height of the wave is the amplitude. Period is one cycle.
Yeah.
This is called the period of the wave. Correct? So the period is
2 pi.
360 degrees or 2 pi radians. Similarly, here also period is 360 degrees or 2 pi radians. Yeah. For tan graph, you're right. So if your y is equal to tan x, what is your tan 90? So 0, 90, 180, 270, 360.
Tan 90 is undefined.
Undefined. So that would be a vertical asymptote.
The same at 270.
270 vertical asymptote. So this goes from 0 to infinity. Then here this will go like this. If you take in the values and plot it, it will go
Yeah,
like
because
this.
at 180 it's 1.
Yeah. If you think of the unit circle, your tan of 180 is 0. Tan of 180 is 0.
Sorry, 0. Sorry, at 1 is at 2, at 135 it's 1, at
Correct.
45,
So that the tan,
135
so
minus
tan
1.
45 is 1.
135
Correct.
is minus 1.
135 is minus 1. 225 is 1 again.
Yeah.
Like that.
And then
Now for this also, what's going to happen is, we'll take 0, pi by 2, pi, 3 pi by 2, and 2 pi.
and 315 is also negative 1.
Yeah. This is how you need to learn your graphs. So what is the period of a tan function?
So,
180 degrees, or in radians it's pi radians. Okay.
yeah.
What do you need to remember in composite function is, so let's consider the case of sine. So y is equal to a sine b x plus c plus d. Now each of this a, b, c, d are important. If you think in terms of transformation, a is your vertical stretch factor.
Yeah.
So A will increase the amplitude. Basically, A is your amplitude. B
increases your period.
Yeah, affects the period. B affects the period of the graph. So B is equal to 2 pi
Oh, I
divided by period.
understand. Sorry.
B is equal to 2 pi divided by the period.
Yeah.
C
is just your
horizontal shift.
Translation.
Horizontal translation.
Left or right.
Left or right.
Is your vertical up or down.
D is your vertical translation up or down. Vertical translation up or down.
So sorry, I didn't mean I didn't answer this. So what I meant was, so the stretch I understood better than how to do the translation.
Okay, we'll come to the translation also. Now, you can also get the value of A by using the maximum y minus minimum y divided by 2. So maximum y value minus the minimum y value divided by 2. That will give you the amplitude. B is equal to 2 pi divided by the period. Yeah. If it's in radians, if it's in degrees, you'll do 360 divided by the period. Yeah. Period is 1 cycle. Remember that when you're looking at sine wave, period is 1 cycle. One crest and one trough fully is your period. C, you have to look at the horizontal translation. So you have to see how far this graph is. This is your C. So if it's to the left, it will be minus C.
Yeah.
If it's to the right, it will be minus C. For the left, it will be
plus C.
Plus C. D is equal to max y plus min y divided by 2. That's your principal axis.
So what's the formula for C?
For C, there's no formula.
You just have to see how much, right?
How much? You have to see how much.
Even for D, can't you just tell by how much up or down it is or no?
No, that's a midpoint. That's your this no disturbance line. Yeah, the principal axis, as we call it. So if you plot y is equal to sine x, so this is your sine x. Now you have to zoom in with, correct? I don't know where my properties are. Plot. I just did plot. So sine x came, because there are a lot of remove one second. Remove one. One second. So sine. So now if your A is the amplitude, correct? So this is when your amplitude increases. Correct? This is when your amplitude is 2. This is when your amplitude is 3. Correct? 2.91. See, look how your graph is, your equation is also changing over here. Okay. Your B affects the period. Now in this case, what's the period? The period is 2 pi.
2 pi, so it will become maybe 3 pi. Or...
Correct. Now when I increase the B, the period will decrease.
Because
2 pi upon period. It's inversely proportional. So when I increase this, the period will decrease. So 2x
became pi.
It became pi. So remember that. So as you increase the value of B, the period decreases. Correct? So let's make it. So let's make it usual. Correct? That's your 1x. Yeah. Okay, fine. Correct? Okay. Now this is your shift. So when your pi is positive, when your C is positive, I mean you'll put a minus sign here. Shifting to the right. You look at where this is shifting, this point. You see how much is this shifting. Correct? So that's your shift, the horizontal shift. And D is your vertical shift. D is very simple to see. D is how far your vertical shifting is taking place. Your cos, same ditto. Okay, so suppose if I put my C as pi by 2. Okay, let's say 0.5 pi. So that means this top part of the graph is shifted. Each thing is shifted. This has shifted here. This has shifted here. So this is shifted by pi by 2. Tan graph. Correct? Now there's nothing like amplitude in this, basically. Correct? So there's no amplitude in this.
Because asymptotes.
Yeah. So as you make it, your graph gets steeper, basically. That's how it affects it. Your B affects the period. B will affect the period. I don't know, it's not responding now. And so on. In this case, you have to simply substitute. See, you don't know the max min. See, to find out the value of A, B and all, you need to get the max min. I don't know the max value.
You know the minimum.
Minimum, okay, I know, but I need both together. Because your A is equal to max minus min divided by 2. So what I need to do is, I'll have to substitute. So your Y is equal to A sine 2x plus D. So you substitute, this is your X, this is your Y. So 3 is equal to A sine 2 pi by 12 plus D. So sine pi by 6. So 3 is equal to sine pi by 6 is what? Sine 30, which is half. Correct? That's your equation 1. Now you substitute this x and y. So minus 3 is equal to A sine 2 into 3 pi by 4 plus D. Correct? So minus 3 is equal to A 3 pi by 2. What is sine 3 pi by 2? Think of the unit circle.
Sine is equal to 270 degrees.
270 degrees. So unit circle, if you're looking at, so this point would be 0 comma minus 1. So that's your minus 1 plus D. That's your equation 2.
Yeah.
Solve them simultaneously. Solve these simultaneously. Correct? So your 3 is equal to 0.5A plus D. That's equation 1. And minus 3 is equal to minus A plus D. That's equation 2. Correct? Change the sign. Cancels off D and D. So that's how much? 3 plus 3 is 6. Is equal to 1.5A. A is equal to 4. Correct?
Yeah.
Then you substitute this in equation 2. Let's say you put in equation 2. So minus 4 plus D. So D is equal to 1. So what does my model become then? So fx is equal to what is it? 4
Sine
sine
2x
2x
plus 1.
plus.
Just substitute the values that you have.
Yeah. Next.
So can I just this is the
Yeah. So you substitute.
so this is fine. Root 3a plus a.
So you substitute this. So 3 by 2 is equal to A sine pi by 3 minus pi by 6 plus D. So 3 by 2 is equal to A sine pi by 6. Correct? Pi by 3 is, so if you take the LCM, this is, yeah, pi by 6 plus D. So sine pi by 6 sine 30, which is half. Correct? So A by 2 plus D. That's the equation 1. The next equation is when you substitute your 8 plus root 3 over 6 is equal to A sine 5 pi by 6 minus pi by 6 plus D. So A plus root 3 over 6. A sine 4 pi by 6. 2 2s are 3s are. So 2 pi by 3. So pi by 3 is, this is 2 pi by 3 is 120. So sine of 120 is same as sine of 60 because 180 minus 120 is 1. Plus, it will be in the second quadrant. So sine 60 is root 3 by 2. So 8 plus root 6, 3 by 6 is equal to A into root 3 by 2 plus D. This is the equation 2. Now you solve this simultaneously. So you can subtract. So 8 plus root 3 by 6 minus 3 by 2 is equal to A by 2. That's A root 3 by 2 minus A upon 2 and plus D minus D. I'm doing 2 minus 1. Equation 2 minus equation 1.
Oh, I think equation 1 minus equation 2.
That doesn't matter. So it will be a negative thing. So this and this cancels out. So now here if you take the LCM, 6, 8 plus root 3 and 2 3s are 6, 3 3s are 9. This would be A, if you remove A common, root 3 minus 1 over 2. So root 3 minus 1 over 6 into 2 upon root 3 minus 1. So this and this cancels. So A is equal to 1/3. Basically I did 2 minus 1.
So